Good morning, everybody. Welcome to exam day. Very exciting. Hopefully not in a bad way, but I'm sure everybody's a little stressed out. It's always hard to do the first exam of the year when you don't really know what to expect and all that. So this morning I don't have anything in particular to tell you that we haven't already gone over, but I want to give you a chance to ask some questions, and we can go through whatever you want, whatever wasn't clear, whatever kind of last minute things you need some help on. This is just the handout from before. We can look at this. We can look at other older ones, whatever. So I'm here. And if you are watching, I have Discord open. I have the chat open as well. And I will answer your questions for the exam. While you're thinking of your questions, just to fill some time here, the exam will start around noon as usual. It's not a super long exam. You know, it's a regular hourly whatever exam as you'd expect, but you do have the full lab time to finish it. I would expect most people will get done well before the end of lab, but you have that time, so you shouldn't feel rushed on it. Hopefully we'll start at noon, but if I have issues with printing or whatever, since I'm only on campus today, we may have to start it a little later, but hopefully it'll be fine. We'll start at noon, and you'll have plenty of time to complete it. We will have to split the class up into two parts, one half in the classroom and one half in the lab. We'll do it just by group A or group B and just a random pick. If you, whichever one you end up in for this exam, you'll be the opposite for the second exam. We will have chairs in the lab, so you don't have to stand up at the benches. And yeah, that's the exam. With the vaccination testing thing, don't forget tomorrow at noon is the deadline for submitting your information. You should have gotten an email about how to do that, and you can click through the site and submit your either your vaccination card or your testing results. And then if you are doing the testing, you need to do that every single week and submit by Thursday at noon for the next week. So you don't have to have anything submitted to come in for the exam today. This starts next week. So you have to have your stuff submitted tomorrow for next week. All right, so I think I've got a pretty decent connection this morning. Yeah, it always seems to work better in the morning than in the evening. I guess fewer people on the internet. Go ahead and post any questions or anything you want me to go over in this last bit before the exam. All right, great. Thanks. Yeah, could I do an example of the ionic compounds where we have the formula and then you have to come up with the name, I guess, right? Yeah, but need to name it. Yeah, sure. Let's do one of those. No, that's fine. I know how that goes. All right. So where we have a formula, but we need to name it. Let's do two of the two different styles. So we'll do Ba with polyatomic ions, sure. So let's do BaCO3, and then let's do trying to think of another good one. Well, we can do a couple. So we can do this one. We can do this one. And we can do that one. Okay. So these are all ionic compounds. And how do we know that? Well, the first one and the third one, we know it because they have metals in the formula. So that's the big clue there. The second one doesn't have any metals, but we can recognize the NH4 as ammonium, so it's also an ion. Another thing the way that you can recognize this is, clearly something weird is going on here, because in a normal, just standard molecular formula, we'd group all the elements together. So the fact that this is separated, and H4 with those hydrogens there, and then OH separate, kind of is a hint that something different's going on here. And NH4 is one of those ions that you should always be looking for. It's a positively charged polyatomic ion, so a cation. So all ionic, which means we're going to use the ionic naming ideas. So then the only question is, are we going to use the parentheses or not? So let's go one by one and see how this works. So for the first one here, BaCO3, I recognize the two ions. So that's the first step, recognizing the ions. This is barium, and this is carbonate. So then I'm going to look at my periodic table and try to look up barium. And I see it is over on the left, number 56 in the second row. So that makes it an alkaline earth metal. And that tells me that it is has a +2 charge, always. So that is a fixed charge. That is a charge that doesn't change. All of those cations in that column always have a +2 charge. So that tells me this is that first type of ionic compounds where I can simply write the names. Barium, carbonate. And that's it. Done. We don't put any parentheses because we know that barium always has a +2 charge. We don't have to worry about calculating any charges or anything like that. We just have to know the names of the cation and the anion, and we list them as such. So the second one here, we have now two polyatomic ions making an ionic compound. So we have to recognize that we have ammonium and hydroxide. And since those charges are always the same, polyatomic ions always have the same charge, as long as you know the charges, you can just list the names. So that's ammonium, hydroxide. That's it. Good. All right. So now we go down to the last one here, FeNO3 . So in this case, again, we recognize the cation as iron and the anion as nitrate. So we look up iron in the periodic table, and it's right here, number 26. And that tells us that that one has various different charges. It's in the middle in those transition metals. So this is going to be one that we have to name with the parentheses. So we can write down the names that we know so far. We know it's going to be iron something. And then hopefully we know that the ion here that's with it is nitrate. And so the last thing is to put something in those parentheses. Now, what do we put in there? We put the charge on iron. So to find the charge on iron, we split the formula up into its pieces. So we've got one iron ion and 3 nitrate ions. That's what this 3 outside the parentheses means. And we know from our memorization of polyatomic ions that each nitrate ion has a -1 charge. So then we have to ask ourselves, what does the charge on iron have to be so that it balances out with the nitrates? And so if we have 3 -1 nitrates, well, then the charge on iron must be +3 or 3 plus to balance that out. So the number that goes in the parentheses here would be 3. Okay, so there's some examples of naming with ionic compounds with polyatomic ions in there. You want to see some other ones, something different? Is that good? Anyone else want to jump in? I'll check Discord as well here. All right, yeah, let's talk about the difference between physical chemical changes and physical chemical properties. Let me see if I can pull up that sheet easily here. All right, so the key difference in both of these is chemical changes and properties always have to do with chemical reactions. So that is some sort of reorganization of atoms. Things that were connected break apart and form new things. Things that were apart come together and form new things. So you're forming different substances from the ones that you started with when you talk about chemical changes. And physical changes, it's still a change. You're still doing something, but the identity of the material, the compound, the element, whatever, has not changed. So some of the things we talked about when we talk about reactivity, this reacts with this to do this, or this is reactive in oxygen, or this corrodes in the presence of oxygen, things like that, where you're talking about reactions, that's a chemical process. Things lighting on fire, right? Burning, combusting, that's chemical. The opposite of that then is physical, where we're not really changing anything. So for example, we talked about separations. Making mixtures and separating mixtures is always physical because you're not changing the compounds, you're not changing the identities of the chemicals themselves, you're just either putting them together and taking them apart. And that can be kind of tricky because sometimes, especially with some of these, it really feels like something chemical is going on. So for example, evaporation, you're taking a solution and you're heating it and driving off the solvent or the liquid, and then you've got a solid left behind. And that clearly looks like you've made a significant change. But if you think about what's really happening, you've evaporated the solvent, which is a physical process, changing the state, leaving behind a solid, which was in solution. So going from solution to solid is also physical because you still have the same thing. So focus on that. Are the chemicals changing or are they staying the same? And that's really the big difference between physical and chemical changes. So then when we move that to properties, we can think about, is this property describing a chemical change or simply describing the substance as it is? So when a property says this chemical looks a particular way, that's a physical property. That's not talking about a change. But when the property says, well, this chemical reacts with water to form whatever, or this chemical is flammable, that's a chemical property now because we're talking about it changing. So remember also changes of state are always physical changes because we're not changing the chemical composition. If we zoom down at the molecular level, which I think we did right here, you can see that the interactions between the particles get stronger as we go to different as we condense the states, or they get weaker and the particles get farther apart as we expand the states, but we never actually change the molecular structure, the way that the atoms are bonded together. Is that helpful? Do you want me to say more about that? Great. Right. Well, I'll hang around for a couple more minutes. If there's anything else, let me know. Otherwise, I will see you at school in a couple hours. Yep. Thanks for the questions. All right. I'll see y'all later. You can send me messages on Discord, or find me right before class on campus if you have any very last minute questions. But hopefully the studying's been going well, and I'll see you in class.